welcome to today's webinar from Velona Systems. I'm particularly delighted to welcome Ian Bell from Manx Telecom. Velona have been a security partner to Manx for about 3 years now, so we've been on a great journey together. I'm also very happy to say Tony Friar, who is on screen as well, has been chair of the GSMA CIPSEC working group, and that working group comprising of quite a lot of service providers and vendors, quite a lot of vendors who've all been really good in bringing forward their knowledge, have all come together to produce a standard for SIP security now. So today's webinar is kind of covering aspects of what SIP security, SIP penetration testing particularly looks like, how you want to do that in an advanced level, how you bring in FS38, and then Tony and Ian will share some of the findings from our pen testing with various people in industry, and we'll have a session with Ian and round it off with a Q&A. So just on the Q&A, a little bit of housekeeping. There's a button down on your bottom right. You can put your answers into the Q&A rather than the chat, because I think stuff gets lost in the chat. So without further ado, the two gentlemen you can see on the screen will be your main hosts today. Tony is our CTO and also chair of CIPSEC, and Ian is the Security and Data Protection Officer for Manx Telecoms Group. So I hand over to you now, Tony.
Yeah, thanks, John. Firstly, thank you everybody for joining this webinar today. I'd also like to especially thank Ian Bell, whose picture you can see here. I'll let Ian say a few brief words about himself, but what I will say, just to add to what John was saying, Ian works for Manx Telecom now. For those of you who are not aware, Manx Telecom basically is the incumbent operator on the Isle of Man. The Isle of Man is a self-governing island, basically between England and the Republic of Ireland. So Ian, shall I just let you say a few words before I start diving into penetration testing?
Yep, thanks, Tony. Yep, as Tony said, I'm the Security and Data Protection Officer for Manx Telecom. So I'm interested in all areas of security, from the data environment, voice environments, security incidents, and data protection.
Okay, thanks, Ian. So what we're going to do, we've got a brief overview here. You'll have seen most of you, in fact, all of you, when you've signed up, will have seen this on the registration page. So basically, we're going to go over a few topics to do with SIP penetration testing. About 2/3 of the way through, we're going to go back to Ian, and we're going to have a discussion. Myself and Ian and John will have a discussion around real world SIP penetration testing for a service provider. And then I will jump back and I will start going over a few more slides related really to what to do when SIP penetration testing has been completed. And then I'll give some thoughts about some future threats, nothing in too much detail, but some high level ideas, scenarios, etc. And then we're going to jump to a Q&A session. So if anybody's got any questions they want myself and or Ian to answer, then please send them through as John described on the using Zoom. So without further ado, let me jump forward, and let me okay, so why run SIP penetration testing? So at a very high level, we're looking for fraud risks, we're looking for privacy breach risks, and we're looking for denial of service risks. Now, later in the slides, we're going to get to an explanation really of how we can look at SIP penetration testing as it has existed, shall we say, until FS38, and SIP penetration testing after that. Now there's a number of additions, but one of the things that FS38 focuses on certainly brings into the penetration testing, SIP penetration testing area, are privacy breaches. So that's something that's generally beyond man-in-the-middle type scenarios. It's something that's not generally been addressed before. So how is risk introduced, and why, how can why does penetration testing need to be performed? Well, you've got vendor issues, configuration issues, and errors. We've all made mistakes when we've been configuring something in the past. Systems integrators could introduce issues during implementations, or even the in-house staff. There could be problems with third-party network nodes, and also as well, penetration testing of any type, not just SIP penetration testing. Because penetration testing at a high level it's the same. It's only when you start to go down the layers whereby the actual protocols and the technology becomes important. So one of the things is testing paper-based security claims. There's a number of times that we've been called in to do this, and sometimes those security claims stand up, sometimes they don't. Now, again, one of the things that FS38 covers, and I will explain in a few slides for those of you who are not aware what FS38 is, and how it came about from the GSMA. But one of the things FS38 focuses on, and it's something that we as Velona focused on as well, well before FS38 was published, and that's why SIP security is more than just SIP. At a very, I guess you could say at a very top level, the traditional approach to SIP penetration testing has been, reconnaissance, footprinting, locate the target, and that's often surprisingly easy. You may have, sip.company.com as the URL for SIP services. Once you've found those targets, then simply send SIP messages to find issues related to fraud, denial of service, and possibly privacy. As I say, was never a main or something that was generally looked for within penetration testing until relatively recently, and we describe it as being part of advanced SIP penetration testing. So this standard traditional approach, it's limited, and it's simply not comprehensive enough. It needs to be much broader, and that broader context is not simply about saying, okay, let's send more SIP messages. Let's be more sophisticated within, what we do with the SIP messages and which ones we use and what we put in the parameters within those SIP messages. It's beyond that. We start to look at provisioning services. We start to look at customer portals. There's a number of different areas that we need to be looking at. We need to broaden this. I should also add as well that there's a tendency to only penetration test the core network and not the SIP endpoints. And this is, well, far from ideal, as the text says. Now, some networks who offer a bring your own device, for example. So some of the sort of OTT players who will say to you, okay, bring your own desk VoIP phone, bring your own soft phone, and here's some SIP credentials. It's obviously a legitimate business model. It's far from ideal because you're giving out SIP credentials, which could be misused, but you're also, the endpoints often have vulnerabilities in them, which can be used to commit fraud or privacy attacks against the core network itself. And those endpoints can have vulnerabilities which leave them open to denial of service attacks. And it's interesting that we find this quite commonly. In fact, I would have to say that it's at least 50-50 between the issues we find on the core networks and the issues that we find on the endpoints. There's probably an argument that says we find slightly more on the endpoints. So why SIP penetration testing needs to constantly evolve. So we're basically in an arms race against the bad guys. That's what it comes down to. It's like any kind of technology which, if compromised, can result in financial gain for the attackers. They have a motive. It's market forces. They have a motive to evolve, and we have to make sure that we are as much as possible ahead of them. Sometimes that's not possible. Sometimes we'll be behind. You know, I don't tend to agree with the view that we are always behind. They are always one step ahead. I think it changes. Sometimes they're ahead, sometimes we're ahead. It just depends on the amount of R&D that's done, etc. And also as well, you know, the financial gain, how big it is. That basically, the bigger the financial gain, the more advanced and numerous the bad guys become. So you're facing a much larger, much more sophisticated opposition. So SIP penetration testing needs to evolve to ensure that the systems being tested have a strong chance of withstanding from these evolving attacks. And a number of things that we're going to discuss here. This is not comprehensive, but there's a number of things. So use of threat modeling. This is something which we're starting, well, we do see in IoT. It is not necessarily something that we generally see a widespread use of in telecom, certainly not to the extent it should be used. There's also a view that threat modeling is simply about you building defenses. But we effectively inverted, and we're not the first people to do this. A number of people use threat modeling to actually help them identify potential risks for penetration testing. So greater use of threat modeling, and also evolve that as well. And that's what we do. We are constantly looking to see how we can evolve the threat modeling we do at the moment. Then we need to look at, we need to consider new attacks against any non-SIP support nodes, because again, you know, the attacks against these nodes are not static, and often these support nodes may be HTTP based. So therefore you have a much greater number of people attacking them than you do with SIP. We need to take R&D inputs from security researchers, or we need to take SIP threat intelligence from SIP honeypots. And we need to take in known vendor specific issues for SIP nodes and endpoints and non-SIP support nodes. And we need to borrow from other areas such as IoT, and also, you know, general internet and IT cybersecurity. We're starting to see that now with the move towards, well, there's a much greater focus on building on security by design for 5G than there were for previous generations. So we're now starting to see more and more borrowing from the, let's say, the internet traditional IT types of cybersecurity worlds. So why regular SIP penetration testing is so important. Okay, we need to ensure highest level of ongoing protection. Now, we can say, okay, well, if we test once when a network or service goes live, isn't that okay? Well, no, it's not. New threats and attacks are developed all the time. So even if nothing changes, we need to make sure that we're regularly checking for the new threats. Now, if you're going to run the same penetration tests against a system that's not changed, then yes, you're wasting your time and your money. But if the penetration tests have evolved, because, you know, we could have the best penetration test in the world at this moment for SIP. I would argue we do actually, and we could run that, and in 6 months' time, we'll have evolved that based upon the things I've said previously and some other areas as well. And we'll have evolved that penetration testing. So it could be 10, 15, 20, even 30% better than it was 6 months before. So the issues, some issues that maybe we didn't find previously would be found now. And that's just simply about iterative improvement. The other thing is that things usually do change anyway. In fact, if a network is put in and it doesn't change, it's almost a stunning miracle, really. Configuration changes take place, and they can introduce security issues. Software upgrades are performed. They introduce potential security issues. Patches are applied, and also we add additional capacity. It could be new hardware, you know, bare metal. It could be a VM that's been added, etc. So these new capacity, these new servers and VM instances, they could be missing patches, they could be missing certain configuration, etc. Okay, so what we're going to do now is we're going to jump to what is FS38. Basically, about 18 months, almost 2 years ago, there were some discussions within the GSMA about the fact that there was a lot of focus, a lot of documents on SS7 diameter, documents being developed at the time for 5G, things like that. But there was nothing about SIP security. The VoLTE standard basically barely mentioned SIP. It was more focused on other areas of VoLTE security. So it was decided that there was a new SIP security standard that was needed. So there is no, up until FS38, there was really no comprehensive worldwide SIP security standard. There were individual internet standards which focused on certain aspects of SIP and certain vulnerabilities, made certain recommendations, etc. There was nothing really comprehensive that covered fixed and mobile networks, and we believe FS38 now does. It was released at the end of April 2021. It took 18 months to develop, and it involved a number of industry experts from a number of different companies. You know, I was very honored and proud to chair the group, to chair the SIP security group, which produced FS38. But there were a number of inputs from some real industry experts who made a real difference to this specification. Now, Velona is the first company in the world, as far as we're aware, to adopt FS38 for SIP penetration testing. And we don't just limit ourselves to SIP penetration testing. Based on FS38, we have other things based on our R&D which haven't made it into FS38, at least not yet. FS38 is applicable to fixed and mobile service providers. We cover SIP access security, SIP interconnects, and the core network. And one of the positions of FS38 is, do not assume you won't be breached. You know, do not assume that your session border controller or any firewall protecting non-SIP nodes is always going to protect you. Assume that you will be breached, and your nodes behind that must have a certain level of resiliency to at least withstand some basic to intermediate attacks. And FS38 covers IMS and non-IMS-based networks, although, as you'd expect, coming from the GSMA, it's mainly focused on IMS-based networks. We also have some enterprise coverage because GSMA members have enterprise customers, but we focus mainly on the external perspective. We don't get into issues on LANs and things like that. FS38, it serves as the basis, more than the basis really, for SIP penetration testing in the following two ways. It basically makes recommendations on testing that covers both SIP and non-SIP support nodes, such as I mentioned previously, such as provisioning and portals. And also there are a number of detailed descriptions of threats that should always be included with any SIP penetration tests. There is a section on testing within FS38 as well, which can serve as the basis for building a very detailed test plan for SIP penetration. So I'm not going to go into all of the details on this slide. You'll be able to look at this slide deck after this if you're interested, after this webinar. But effectively, the pie chart on the left is effectively an approximate look at the splits between SIP penetration testing and testing of provisioning portals, provisioning service, sorry, customer portals, things like that. Now, this will vary based upon the network, based on the customer, based upon exactly what needs to be tested for that particular project. Now, I'm going to briefly cover our testing approach, although this is not, how would I say, not dramatically different. In fact, it's probably not that different at all, really, from the correct way to approach a penetration testing engagement. There needs to be a clear definition and agreement in step number one. We have come across quite a number of examples whereby, for not just for SIP penetration testing, but other areas of penetration testing, whereby the definition really hasn't been agreed. There's a view that the penetration tester will just turn up and start sending things, and that's basically it. Start sending messages, and that's it. That's not the approach. The engagement needs to be very, very clear in its definition. Then we move on to the reconnaissance and verification. So basically, we need to, we could call this SIP footprinting. That's what FS38 refers to it as. We check for a number of things, and some of this is basic vulnerability checking as well, port scanning, things like that. Then we start to run the end-to-end tests, and that includes things like known vulnerabilities, specific vendor vulnerabilities, torture testing, privacy checks, that kind of thing. Potentially performance and load testing, and we start to look at provisioning systems and self-care as well, if that's a part of the engagement. Then we basically perform an analysis on the vulnerability, including an estimation of business impact. And again, that's, any kind of SIP penetration testing engagement needs to, any issues that are found, it needs to show what the potential impact is on the business. Then we get into the reporting and debrief. We'll provide an executive level management report, workshops, in-depth technical reports, and we also provide 90 days of support afterwards, so that we can retest any issues that have been found that may have been fixed by patches or software upgrades or configuration changes. And while, I've said here that this is Velona's advanced SIP penetration testing approach, this is an approach really, at a relatively, well, at a high and even a detail level that we'd expect most penetration testing to take. Now, I mentioned earlier as well that until FS38, I would argue that we could say SIP penetration testing fell into what we could call standard SIP. There'd be checks, there'd be denial of service checks, and checks against known vulnerabilities. As a general rule, and I should be clear here, there's exceptions. There are some SIP penetration testers who would do one or more of the things which have got a red cross against them, but privacy is not generally covered. Advanced fraud, advanced denial of service, performance and load testing, provisioning and customer portal checks were often seen as separate from SIP penetration testing, and it wasn't really standards based. Now FS38 aims to fix that. So I would argue that advanced SIP penetration testing on the right hand side, with all the green ticks, covers that. Okay, how to assess the severity of the findings. So simply producing a report and basically saying, okay, these are the issues we found, and that's it. It's often not particularly helpful, certainly unless even to be honest, even if people within the customer, within the service provider or the enterprise, even if they are experts within the domain, there often needs to be some kind of external assessment of the risks based of the vulnerabilities which have been found. What we do here is, and again, this is something that should be provided by any kind of penetration testing, be it for SIP or otherwise. There should be a severity rating. We should be looking at critical or high or medium or low or advisory ratings. So if we look at critical, it could basically mean that a malformed SIP message could take down one or more nodes within the network or enterprise, and we found that kind of issue before. And right down to advisory, which is something like the software version will be obsolete in 6 months' time. Now, before we get to the bit I'm looking forward to, and I suspect that a lot of you are looking forward to, the discussion with Ian Bell, I'm going to briefly go through some of the more surprising vulnerabilities we found over the years of SIP penetration testing. I should add as well that while we've got Ian from Manx Telecom on the call, these are not issues that we found at Manx Telecom, and all the issues that we're talking about here have actually been fixed, certainly on the particular vendors nodes on which we found them. There are some call flows for some of these, which we'll go to in a second. But the first one was it was basically for an IMS application server, and it was the ability to download SIP credentials from the customer portal using a crafted HTTP message. So you could effectively download the SIP username and password, register a device, and start making lots of calls. Then there is another one that we found on a SIP endpoint. This one was seen as extremely serious and was reported to the UK National Cybersecurity Centre. Basically, it is you can commit fraud and privacy attacks against this SIP endpoint. You send what's known as a SIP refer message, and that message instructs the endpoint to initiate a call. Now, depending on how you craft that refer message, you can basically have that endpoint send set up a call to an internet-based SIP server, which could record all the audio, because the phone sets up a call, and unless you're looking at the screen at the time, you don't know that the phone has made a call. So it becomes a room monitoring device, and the variation of that attack is just with a different parameter in that SIP refer message, and you tell the endpoint to actually make a call through the service provider's network, or potentially through the PBX if it's an enterprise, and you start to initiate fraudulent calls to premium rate numbers. So that was very interesting. It was also interesting how long it took for the endpoint vendor to resolve what we would regard as, well, what we did regard as a critical issue. Now, this one was very interesting. We found this in the early days of Velona. And you basically could cause a session border controller denial of service by sending the wrong SDP length. So I'm aware that a lot of people on the call won't know the details, the in-depth details of SIP. So let me just say that all SIP messages can carry what they call a message body. And that message body can be used to describe the codecs you're going to use on the call, or it can be used to carry XML message bodies and things like that. But the SIP message itself should actually say how long that message body is going to be. So when we send a SIP message, we said, okay, well, the message body is 50,000 bytes, which is, you would never see that in reality. You might see 500, 600, 1,000, something like that, maybe a little bit longer for some scenarios. But the message that we were sending was only 500 bytes. So the session border controller was waiting for the other 49,500 bytes and stopped processing any traffic until it received it. So why was this so interesting for us? Well, first of all, it was a session border controller, so there was interest there. Secondly, it's literally a textbook attack. This is literally described in a book on SIP security, which was written years ago. And the other point is that the vendor initially disputed the findings and said it couldn't happen because they subscribed to a threat database, which is not a SIP-focused threat database. But as the attack had not been reported before, it couldn't happen, which is a very interesting approach to take. And the reason I mention this last point is because there's a very serious point there about picking vendors with a focus on security who are not going to come out with comments like this. Final one on this, reboot of SIP endpoints. This is such a common thing. We find this so often. It's been around for years. Shouldn't be a surprise to us. It sort of isn't, but it's a surprise, but it's still there and it's still not being resolved. Some devices can protect against it, but some can't, certainly not effectively. That is basically the sort of overview of SIP penetration testing and how FS38 is beneficial to that, how FS38 came about, and basically how FS38 can be used as more than just the basis for SIP penetration testing, and how it aims to introduce or to drive really standards-based SIP penetration testing, and how we at Velona are using it. So what I want to do now is move on to the panel discussion with Ian Bell of Manx Telecom. So I'm going to stop sharing the slides here. So you get to see us both side by side. So Ian, thank you again for joining us. I've got a few questions for you, which I'm going to start going through, and if you could give sure your answers, obviously not just with me, but with everybody on the call. So I will give a little bit more background as well, if I've not done before, about Velona Systems have been working with Manx Telecom for, I think, just under 3 years now. And we basically test the IMS-based SIP offerings, and that's for enterprise and consumer services. And we test both the core network and the SIP endpoints, as well as some related systems. So what I'd like to ask you, Ian, to start off with, what did you want to achieve when you contacted us for external SIP penetration testing?
Yeah, it's a good question. I mean, whenever you start on any project, you've got a certain amount of trust in your vendors, trust in your people, trust in your processes, and in yourself. So pen testing, it's a way of verifying that trust. So I do harp on about this at work a lot. Security is trust and verify. And there's no point just blindly trusting anyone. And we see that a lot with the supply chain attacks and the information going on at the moment. So yeah, penetration testing, it's about that verification. So we have a good idea before we engage in pen testing of what our risks are and what they should be. And that test allows us to verify that we understand those risks themselves and make sure we haven't missed anything. Yeah.
Okay, great, thank you. Okay, so next question. It's a slightly how would I say, a slightly longer one, I guess. So when we first started discussing SIP penetration testing with you guys, one of the things that we found interesting, and I've got to say refreshing, and I've alluded to this earlier in the call, you guys weren't just focused on the core network. You did see, and we get those requests about testing the core network relatively frequently, but you were also focused on the SIP endpoints, which I think at the time it was IP phones from at least 2 vendors and an ATA as well. Yeah, and you wanted us to test those as well. So I'm just in, if you could just maybe share with us what your thinking was behind that, because we often go into places and we say, okay, well, you want the core network testing, but we'd also recommend the endpoints. And there's a sort of, I don't know, almost a reluctance to even consider them as a threat.
Yeah, I mean, the key thing here is an endpoint is not a telephone. What you've got with an endpoint, you've got a processor with a network connection, which in security is one of the most dangerous things you can have, isn't it? Not only that, it's connected to some of our key infrastructure, things that we wouldn't normally want people talking to or having access to. And it's something that I and the team at Manx Telecom have less control over. Not only do we have less control, we can't control, you know, if a user decides to suddenly update their own firmware or apply some software or something that we've not tested, you know, we've got no control. So I want to know when we're testing the endpoint, you know, what are the risks? Is this a potential for fraud? Have we got denial of service attacks that can originate from this device, or are we going to get some privacy issues like some of the ones you've discussed earlier in the talk? So yeah, it's trying to understand, you know, the whole picture. So as you say, it's not just about the core; it's everything that connects to that. Defense in depth. It's you know, understanding the full picture.
Yeah. Okay, thank you. And I'd have to say that we, you know, we agree totally with that approach, and that thinking really. You know, we just cannot continue down the path of just seeing things in isolation. Yeah. So on the voice side, your role covers both fraud and security. Now, the Velona threat intelligence data, so as you know, and there's some people on this call will know already, we run SIP honeypots. We've got 13 SIP honeypots in 12 different countries, 2 in the US. That's a big part. It's not the only part, but it's a big part of the feed into our SIP intelligence. And the honeypots, as well as the other feeds, are showing that the SIP attacks are becoming more sophisticated, and I would say that's been going on for the best part of 2 years now, and arguably actually longer than now, depending on how you look at it. The risk to SIP has mainly been seen as coming from fraud until this point, and I understand why. That's where the revenue loss comes from, etc. But denial of service and service and privacy attacks, I suspect will become, well, I'm absolutely convinced, actually, because of the honeypot data especially, are becoming significant risks. So could I get your view on that, please?
Yeah, I 100% agree. With fraud, you've got a clear and direct cost to the business. It's quite easy to measure and sort of calculate, you know, your benefits for security, protecting against it, and the cost in business if someone exploits it. Privacy and denial of service, they're less easy to measure. Most of the benefits you gain are from preventing an attack or, you know, stopping it from happening, and you can't put a figure to that. The other side, with fraud, most people tend to look at that direct cost. So many minutes of calls were made, and that cost the business so much. Some businesses tend to forget about the recovery time afterwards, and it's that recovery time that we need, that is involved in privacy and denial of service attacks.
Yeah, and again, I mean, that is something that we would agree with completely. It is, I mean, with the penetration testing that we get call to do for most companies, not all, still the majority of it is based on fraud, because you say this is like it's the easy thing to quantify, it's the thing to check. And but I think that once the denial of service attacks start to become much more widespread, and I'm not talking about, I should say here as well, I'm not so much talking volumetric denial of service attacks don't really concern me that much. It's actually the sort of the more crafted message type attacks. That's what concerns me more. So yeah. Okay, thank you. Was there any one thing, or if you want to, more than one thing that surprised you about the penetration testing?
There was certainly some interesting results, but it comes back to that test and verify. So we went in, we were expecting, more or less to have our risks validated. There were a couple of things that, which, as I say, were surprising, especially on the endpoint side. But yeah, it was interesting.
Okay. And you went for external SIP-based, external SIP penetration testing, and we speak to some service providers who say that they're happy to do it all internally, and you guys obviously didn't. Could you sort of shed some light on why not?
It's a combination of a few things. We do have some of that skill set internally, and that's been developing over the course of the few years. But again, it's trust and verify. It's no point just sticking with one person and asking them to do the same thing over and over again. Getting you guys in and testing us and making sure that things are working. We see your stuff on the research and development side, and that's really useful, and it helps informs us internally as well. So it's getting that bigger picture and getting that, all these things working together. So you're looking at, from the core to the endpoint, internally and externally.
Yeah. Okay, great. We've been your advanced SIP security partner now for some time. So I'm wondering if there's any closing remarks. This would be a really bad time to say that you're actually not happy.
I think what was refreshing with you guys is it was, I guess you said we started engaging with you about 3 years ago, and we're still engaging with you now. And it's not just here's the test, here's the report, see you later. It's it's a joint effort, and we're working together. And with things like FS38, it's improving the SIP for the wider, the company, the world. If I can make it that grand. But yeah, it's that continuous discussion and movement of security and the evangelizing SIP security.
Yeah. Okay, great. Thank you. I mean, we just to sort of agree with you. I mean, we put a lot of effort into R&D, and we've been, I think, believers for a long time that there's a lot we can take from the broader cybersecurity world. Which this has come up in discussions that we've had with you guys. Some of this is in terms of general approaches, things like defense in depth and things like that, which is more of a cyber approach from a telecom support, until we're starting to move in that direction now. But other things are more specific, such as certain penetration testing techniques and things. And 5G is sort of driving us down that path far more than it ever has as an industry. So yeah. So I'd just like to say thanks again, Ian, for joining us and for taking part in this, in this discussion. It's always interesting to get a customer with real world experience of this on the SIP and IMS fraud security side of things, who's dealing with it day in, day out. I've got a few more slides to run through, then we'll get to the Q&A. I better start speeding things up so we can get as many questions in as possible. So thank you again, Ian.
Thanks, yeah, thanks for inviting me.
Thank you. So let me share the screen again. Okay. So let's move on to the. We've got a few more slides here, then we'll get to the Q&A, as I say. So what to do when the testing is over? So effectively, and again, this is not specific to SIP penetration testing or to advanced SIP penetration testing. This is generally specific to all penetration testing. So we need a report detailing the results from the testing. And the report should not be widely distributed within the commissioning company. Even at Velona, excuse me, we don't circulate specific reports widely within the company, as few eyes as possible, really. Results need to be analysed and assessed, and the priority of the issues agreed with the customer, and then a project plan put in place. And again, this is normally something that the penetration tester should be involved with. Any issues that can be resolved via configuration changes should be immediately, if possible, or certainly as soon as possible. And obviously those changes should be tested as well. Any firmware and software issues should be immediately reported to the relevant vendor, and a timeline for a fix agreed. And actually this again comes back slightly to what I was saying earlier, that we some vendors are better than others when it comes to security. Some are in the middle, and we have had some very concerning, with several vendors, we've had very concerning, basically just dismissals of very serious issues we found. Or in one case, we had a company saying they would only resolve a critical issue if our customer was prepared to buy tens of thousands of units. So very briefly, future threats. As I said on the discussion with Ian, exploitative SIP denial of service attacks rather than volumetric, they're increasing. They'll continue to do so. Our honeypot data is showing this very clearly. Vaulty SIP attacks, as opposed to sort of general 4G type issues, vaulty SIP attacks will become more sophisticated and numerous. We were involved within the GSMA in dealing with one of those late last year. That's now in the public domain. It's not something we found, it was other researchers who found that. Those same SIP attacks will likely apply to voice over the 5G as well, because of the similarities. So the more we can fix now, the better. Privacy attacks, as I mentioned earlier as well, they're going to become, there's more and more of a need. We're seeing this on SS7 diameter, and we know some of these attacks are taking place on SIP as well, and I think we're going to see more. And state actors. We've shared our information with a number of people in the broader cyber security world, and the general agreement is that some of the stuff we're seeing, a lot of the stuff on the exploitative DOS type stuff is state actors. Next steps in the security journey, it comes down to defense in depth, really. We can't rely on just session border controllers and firewalls. We need to be looking at encryption. Yes, there's a cost associated with encrypting, but we're reaching the point now where it's becoming too much of a risk not to. Penetration testing is a part of defense in depth. It's one of those elements. Intrusion detection systems, threat intelligence, fraud and management systems. Most service providers have that already in place. I would argue taking direct SIP feeds into those is useful, certainly in terms of the forensics side of things after an attack. If you have the original SIP messaging, then there's more that you can do on the forensics side. Machine learning, AI, deep learning, these are the buzzwords. They're useful, but they need to be applied properly with a certain amount of cynicism, but not dismissed at all, because there are real values to them. And 365 24/7 protection, basically. Now, Q&A session. We've got 11 minutes left, a little bit longer than I'd intended to run for, but we've still got a good 10, 11 minutes. So, John, I'll hand back to you.
Yeah, just coming off the video. So there's a good few come in. I don't think we'll have time for them all, so I'll just maybe pick a few. The first one is a kind of an interesting non-SIP one. I think it's to Ian. What's the difference about being a security officer in a telco rather than your other roles? So I think that's to you, Ian.
Yeah, it's a good question. And yeah, I started in telco security 3 years ago with Manx Telecom, and prior to that, I was in banking. What's different? I guess the difference is that a lot of the technology and the protocols and things that our telecom channels are using are actually quite ancient. I think some of the principles around SS7 were being used with semaphore and telegraph. So you've got processes which are tried and tested and been there a long time, but also the attacks and the exploits of those processes have been tried and tested for a long time as well. And people are always trying to find new ways to implement those same attacks. I think the similarity, though, which is quite striking, is that all these all these things are the same. I guess this constant building on. We've got algorithms. I've forgotten.
It's okay, no problem. So yeah, I guess we'll move on to another one. So I think could be. I think it's for you again, really. So it's what worries you most as the security officer working for a service provider? About to move to an IP-based telephony.
Okay, so
yeah, that's the question.
What worries me most? It's the things you don't think of. That's what keeps me up at night. Is have I covered everything? Specifically around IP and SIP. There's that blurring of the boundaries now. With SIP, you've got connections from IP networks, which you wouldn't have before, certainly not this great number. So it's just the scale, and the attackers are emerging. So you're looking, people who would only look at IP networks before are starting to apply their tradecraft to telephone networks, and they're applying some of the things they've learned and attacking us in new ways and developing these attacks.
Okay.
Just to come in on,
yeah.
Just to come in on that one as well. I mean, I would agree. I mean, it comes back to what I was saying earlier about how, there's a view, SIP penetration testing, it's just SIP. Well, it can't be, because you've got the people who are developing, who come from that internet background, that IP background, and they're saying, okay, well, we'll start doing SIP as well. But they also have that existing skill set about attacking, customer portals, provisioning servers, things like that. I mean, we've done tests whereby we put, SIP endpoints available on a public IP address, and yes, we get SIP attacks on them within the hour in most cases, but also you log in and find out somebody's actually, if you've left the default passwords on, they've hacked the GUI configuration screen, within an hour, 2 hours, something like that. So yeah.
Very good. This is from Asashana Vodafone. What's new in FS38 that makes it so much better as a standard for SIP security? Should we take that one, Tony, maybe? Or
yeah, okay.
Yeah, you can chime in as well if you want.
Yeah. So it's a very good question. FS38 it's in parts, it's very easy to say it's an umbrella standard, but it's not quite true. It is part umbrella standard. So there were a lot of separate, as I mentioned at the beginning of this webinar, there were a lot of separate things like certainly RFCs, internet RFCs, which would describe very specific issues or vulnerabilities, or maybe some general advice on SIP security and things like that. But there was nothing really that brought it together and included real-world attacks against fixed and mobile networks. The internet RFCs may have included some individual type attacks that have been seen in the wild, but our FS38 brings all of that together. It describes those attacks, it describes the countermeasures, it includes a lot of R&D. A lot of that is from Velona, but we've taken research R&D from other organizations as well. And the countermeasures are described here for all the interface types, access, interconnect. And we also, as I mentioned earlier, we discuss things like how to, things you should be looking for when you're testing. It's not a full-blown test plan, it doesn't include one, but it covers those kind of things.
Yeah, and it's pulling everything into one place. I mean, you could say that some of these things are covered in other areas, but the fact that we've now got one standard, one document that we can all refer to, we know what we're talking as a community. We've got the full list of controls and things we can apply, and it's like with ISO 27000. Before that, yes, people were still thinking about these things, but having it of these controls and this framework in place allows everyone to sort of think about things from an approved or understood starting point.
Yeah, very much. And I'd also add as well that there's also, discussions about adding a version 2 of FS38. I mean, if we hadn't have stopped writing, we'd have been going for another 6 to 12 months. I mean, I've got something like 120 points to consider adding into the next version, and I'm sure other people on the group have as well. So yeah.
Okay, can I just jump to another couple just quick before we close? I think so. There's one about automation. It's how much can you automate, and what's the balance between free testing and automation? I think.
Yeah. I would say that you can automate a lot. I mean, that's one of the things, that we, well, as both of you know, that's one of the things that we do. We automate as much as we can. It allows things to be run quickly, at a lower cost, etc. There is an element, I'm never quite sure how to put this. There's that feedback. You'll see certain things when you're looking at the tests going in front of you, and you look at the tests and you think, that's a strange response, and the automation wouldn't pick it up. It would just say, well, that's failed or passed, etc. But you look at it, you think, well, that response isn't quite normal, but it's okay, but it may indicate something else. And it's not that you can't automate those things, I mean, but it's iterative as we go over time, and as time passes, we'll add that into the automation. But there's also the sort of the free thinking. When they say the free test, I'm assuming they mean kind of free thinking, creative assessment type thing. You look at any kind of penetration testing, one of the ways you improve it is by looking at it and saying, okay, well, that's what can we do now? Let's just spend a few hours just trying something based on that result, which we don't have in the test plan or in the automated software. So yeah.
Okay. Next one I think is for you, Ian. How important do you as a CSP view encryption? I suppose you're talking about SIP encryption or all aspects of encryption, but how important is encryption is the question.
Yes, in one of my previous roles, I used to work for the crypto team. So crypto is fundamentally important for me. The trade-off, as you mentioned earlier, Tony, is the performance hit. So in an ideal world, we'd encrypt everything. Encryption in communication has been going back to the Roman times with things like the Caesar cipher and things like that. So it is fundamentally, I think generally everyone recognises that it's important. It's always down to that risk assessment and balancing the cost of implementation, the cost of performance, and so on. So it's for me, it's fundamental, but it's always down to that risk assessment and the balance between the bean counters and the security people.
Yeah, I suppose it's kind of a follow on there. There's one, have you seen a difference in the level of attacks since you started, you know, in your last 3 years on the networks?
Not really. There's the level, yeah, it's more or less the same. I think we are seeing some interesting things. And through your help, we've avoided some other interesting things. So it's more or less the same at the moment. But as Tony said before, denial of service and privacy attacks, I think, are going to be fundamental in the future.
Yeah. Okay. I think we're pretty much out of time, guys. So I think it's probably a good time to close. Just want to thank everyone for attending. We had quite a wide attendance base, I think. A couple of Danish, lots of different parts of the world. So a very interesting session. We will be running more sessions on threat intelligence and, you know, real-time analysis of SIP messaging, deeper kind of engineering webinars down the line. So I just want to thank Ian particularly for taking time out of a busy CSP to come and sit in with us. And thank you, Tony. And thank you all very, very much for attending.